going back to this hyperbola, x squared by a squared minus y squared by b squared equal to 1, where b squared is a squared into e squared minus 1, right? E is the eccentricity of the hyperbola, and this hyperbola was like this: a0, this is a prime minus a0, right? Foci was minus ae0 and plus ae0, and there were the two directrices, x equal to a by e and minus a by e, and so on and so forth, right? Now, halfway between a and a prime was the center of the hyperbola, which is 0, 0, which is 0, 0. The center of the hyperbola is also the origin because of our designs, right? With C as the center. See, these lengths are A units, isn't it? This is A units, this is also A units. With C as the center, if you draw a circle, what's the equation of this circle? X squared plus y squared is A square is the equation of the circle. This circle, let me call it something. This circle x squared plus y squared is a square, is called the auxiliary circle of the hyperbola. It shares a common center with the hyperbola, and its radius is the semi-transverse axis. Its radius is the semi-transverse axis A. Yes or no? Now, look, if I look at any point on this hyperbola P, x comma y, if I look at any point on this hyperbola, these are two branches of the hyperbola. These are two branches of the hyperbola, right? Let me drop a perpendicular from P onto the transverse axis. This is my transverse axis. I am drawing a perpendicular from P onto the transverse axis. Let me call this point Q. Let me call this point Q. From Q, I can draw a tangent to the circle. I can draw a tangent to the circle. Yes or no? Right now? I'll draw a tangent to the circle. From the foot of the perpendicular, I'll draw a tangent to the circle. QT. The radius at the point of tangency will be perpendicular to the tangent, right? This would be 90 degrees. Now, if this angle is theta, this is A units, the radius of this circle, right? This theta would be different for different p's on the hyperbola. This theta would be different for different p's on the hyperbola, right? Yes or no? What is this length CQ? In this right angle triangle, can you tell me what is this length CQ? A sec theta, right? CQ is A sec theta, isn't it? So Q has coordinates A sec theta, X coordinate A sec theta, right? Now, if you plug in X as A sec theta here, if you plug in X as A sec theta, you will get Y as B tan theta. If you plug in X as A sec theta, right? B also has X coordinate A sec theta, isn't it? And if you want to find the Y of this point, what would you do? Plug in X as A sec theta, you will get Y as B tan theta. You will get Y as B tan theta. This theta is called the eccentric angle of the point P. Right? We had eccentric angles in ellipses also, remember that? This theta is called the eccentric angle of the point P. Of the point P. This theta is called the eccentric angle of the point P. Now, there is an important thing here. Look, So how do you obtain the eccentric angle? To obtain the eccentric angle for any point, what would you do? From any point on any branch, you will first drop a perpendicular onto the transverse axis. Onto the transverse axis, right? From that point, you would draw a tangent to the circle. And then you have a radius at the point of tangency. The angle that this radius would make with this direction, that would be the eccentric angle of the point P. And then this point, if this is theta, then this point would be a sec theta, b tan theta, right? Now, there is an important remark here that I want to make. And for some reason, I do not know why, but people choose to be oblivious of this. So this is my auxiliary circle. This is my auxiliary circle. Huh? Now, this is my hyperbola. It's also your hyperbola. This is auxiliary circle. X square plus y square is a square. So I know if I had a point in this branch, I dropped a perpendicular, a tangent, and then radius at the point of tangency, and then I obtained theta for this point. Then I call this point a sec theta, b tan theta. But problem is, this is my positive x-axis, this is my positive y-axis, right? Now if I had a point here in this branch, right? And I dropped a perpendicular here. Please take notice of what I'm saying. Huh? If I dropped a perpendicular here, say call it PQ. And like before, to obtain my theta for the point P, and then eventually I'll call P as a sec theta, b tan theta based on the theta that I obtained. And from Q, if I dropped a perpendicular like this, I drew a tangent like this, QT, and then I drew the radius, then my theta is this. This will be my theta for this point. Now, do you realize this theta is obtuse? This theta is obtuse. If I did this, then this point P would be like a sec theta, b tan theta. Now, problem is, if this is how I drew my tangent for a point P here, then if theta is obtuse, do you realize sec theta would be negative? And tan theta will also be negative. But for this point, so that means x and y are both negative, but that's not the case, right? In this case, x is negative for this point, but y is positive. That means drawing a tangent like this is wrong. For this point, drawing a tangent this way is not giving me consistency. Yes or no? It's giving me a sec theta, b tan theta. Theta is obtuse this time. Sec theta would be negative, tan theta would be negative. So both x and y for this point is negative. But for this point, y is positive, x is negative. Yes or no? Which means this theta obtained is wrong for this point, right? What I do is, see, this is what I do. Okay. What I do is the following. Alright, there is only one way I can drop a perpendicular. Alright. This time, what I do is, say this is my center, I draw a tangent this way. Alright, this is my tangent, QT. This is the radius at the point of tangency, A. This is the radius at the point of tangency, A. And now if this is my radius, this will be my theta. Yes or no? This theta lies in the third quadrant. And in the third quadrant, this will be negative, but this will be positive. So this is appropriate. For a point on this part, you have to draw a tangent to this half of the circle to get your theta, not the upper half. Yes or no? Otherwise, you'll get it all wrong. Right? Similarly, do you understand what I'm saying? है ना, इसमें theta इस point के लिए eccentric angle theta is this, not what I showed earlier. Right? Also, if I have a point P here, then to get the eccentric angle, what I'll do is, again like before, that means now this part of this branch, there is an upper part of this branch, there is a lower part of this branch. Now I draw a perpendicular like this, PQ, right? In this case, x and y should be both negative. That means sec theta and tan theta both should be negative. That means theta must be obtuse. So to get the theta for this point, from this Q, I draw a tangent like this. This is my radius, and this is my theta, which lies in the second quadrant. Now, A sec theta, B tan theta, both would be negative. Which is what you want. A sec theta, B tan theta, both to be negative. So, to get the theta for this point, I'll drop a perpendicular like this. I'll draw a tangent like this. I'll draw a radius like this. I'll get my appropriate theta for points in the lower branch of the lower part of the left branch. Naki. If I had a point P here, in this case x is positive but y is negative. So sec theta should be positive but tan theta should be negative for this point. Such should be theta, which is the case. Because now if I draw a perpendicular like this, I should then draw a tangent this way. Right? I should then draw a tangent this way. This would be my radius at the point of tangency. This is my Q. This is my C. And do you realize this then becomes the theta which lies in the fourth quadrant? This becomes the theta which lies in the fourth quadrant. And if theta lies in the fourth quadrant, sec theta will be positive, tan theta would be negative. So the coordinates of P, which are like A sec theta, B tan theta, you will get the appropriate signs for sec theta and tan theta. Yes or no? Do you all understand this? So, in a very general sense, for every point P on any one of the two branches, there is going to be an eccentric angle theta associated with it. And the coordinates of that point for a standard hyperbola is going to be A sec theta, B tan theta. A sec theta, B tan theta would be the coordinates of that point. Yes or no?